So we're going to look at some object-oriented design principles. Mainly four: encapsulation, integrity, abstraction, and overloading. So encapsulation is also called data hiding, and that's actually what it does. It hides the internal representation of an object from outside the object. And the benefits of those are that we get higher integrity and a higher level of abstraction. So let's look at integrity and abstraction. Integrity is because only the methods of the object can modify the variables in it. So it means that not everybody can touch these variables, only through the invocation or the calling of the methods in the class. So in, for example, our circle, we can only change the color and the radius through the constructor when we create an instance of this class, through the set radius, the setter, and the set color. And there's no other way we can do to change the value of these variables. And this makes that the integrity gets higher, because we know that if we change variables, we have invoked or called a method of the object. It also helps abstraction. Abstraction, as we've already seen in the figures, is a way to focus only on the important facts. Because sometimes to use a class, we don't need to know all the details of how it works. Yeah, sometimes we don't even want to know. To drive my car, I don't want to know how it actually works. I just want to know how to start the engine, push the throttle, release it, hit the brake, release the brake, turn the wheel, push the clutch and release the clutch. I don't need to know anything else to drive my car. I don't need to know how the gasoline and the air are mixed and ignited in order to start it up. I just want to drive my car. And if something happens with the mixture of the gasoline in the air and the car doesn't work, I'll just take it to the garage. So the other object-oriented design principle is overloading. Overloading means that a class can have one method with the same name. It has the same name, but a different list of parameters. So the compiler knows which one to call because it can look at the parameter list and see which one you were trying to invoke. So here we see an example of a pencil, a class pencil that has an attribute price, which has type float. And here we see two setters. One setter that has one argument, a float, that wants to set a new price. So we assign new price to our attribute price. And here we see another setter. We see that the argument that this setter has is different. It has a different type. The type of the argument is another pencil. And what we do, we get the price from that pencil and we assign it to the price of our current pencil. So here we have two methods with the same name, set price, but with different types of arguments. And so the compiler knows that if we call set price with a float, it will call this one. And if we call set price with another pencil, it will call this one. And this is how we can overload the names of methods. In the next part, we'll look more at these data types.